Hello. In this activity, we are going to look at plate boundaries, and you're going to answer the questions that are on this activity, and that's 1 through 15. So let's get started on this activity, and hopefully we'll finish it in 8 to 10 minutes. Why are the Earth's continents constantly moving? Well, this animation will help answer that question as a review. So we have our two plates. We have our oceanic crust on top of the upper mantle, right, forming a lithospheric plate. We have our oceanic crust on top of the mantle, and we also have a continental crust on top of the mantle. And what happens is that we have the convection currents in our Earth, and those convection currents are pulling the plates along. They are being new seafloors being made at a spreading center, all right, in the divergent boundary. And as those plates are being pulled apart by these convection currents, new seafloor is made, and as it is made, it is constantly expanding. Well, on top of those plates there can be continents, and continents are not destroyed because they are less dense, and so they tend to exist on top of the Earth. And as those plates move, the continents move also. So how many tectonic plates are there? Well, here are the plates on Earth. These are the major ones. There are actually more than this, but a lot of them are minor. And if you counted them, the major plates, you would see that there are about 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are roughly 15 to 16. Okay, I'm not counting the Juan de Fuca plate, which could be a minor plate. So the number tends to be 15 to 16. List the name of the plate that contains California. So for you, hopefully geology people, we have our, let's see if we can separate this a little bit better. So we have our land masses. We have South America, North America, Europe, Asia, Africa, right? So we are in North America, right? Canada is above us, and California is on the west coast, so we are actually right here. So list the name of the plate that contains California. What is the North American plate? Where is the North American plate being created? So the North American plate is being created where there's a spreading zone. So let's look to see where the mid-ocean ridges are. And this indicates the mid-ocean ridges, and that means that there's spreading zones. So the North American plate is being created here. And what is the name of the plate that is east? Okay, so this is east. And the name of the plate that is east of the North American plate is the Eurasian plate. So these two plates are moving in different directions. Eurasian plate is moving to the right, and the North American plate is moving to the left. What are the names of the two plates that lie to the west of the North American plate? So we have our North American plate, and there's actually 3 different answers we could have for that. And so the two plates that are directly west of California are the Juan de Fuca plate, which is being slowly disappearing, and there are 3 different subduction zones, or 3 different spreading zones in that. It's an area of high earthquakes. We also have the Pacific plate, but if you go over, you can also see that there's the Eurasian plate. So I'll take whatever answers you'd like. We have the Juan de Fuca, Pacific, or Eurasian plates are to the west of the North American plate. How thick is the continental oceanic crust? So we're going to look at this interactive dynamic Earth page, And if we go ahead and read this first part, you can see that the continental crust, while this type is found under the oceans, is called oceanic crust. The continental crust is thicker. It's between 20 to 40 miles or 35 to 70 kilometers thick, and it's usually older. The oceanic crust is only 4 to 6 miles or 7 to 10 kilometers thick. So you may remember this interactive that we had before, and it shows the relative depth in kilometers, and you can totally see that the continental crust goes as high as 70, which is right where India is pushing into Eurasia, making the highest mountain range in the world, and it can go all the way down to the edge, which is like 10 or so kilometers. Right? In the ocean, again, it goes from 0 to 10, all right? And so that fits with what was being said here, that it is 7 to 10 kilometers thick, and again, 35 to 70 kilometers thick. And what is a plate boundary? It is the border between two tectonic plates, which is called a boundary. So a plate boundary is the border between two tectonic plates. And so we have these plates here. So there are three types of plate boundaries. They are the convergent boundary. In a convergent boundary, the two plates are converging. That means that they're moving towards each other. There's a divergent boundary. And divergent, if you watch the movie Divergent, it means that things are separating. Okay, so we have separating going on. We have two plates moving away from each other. And finally, we have a transform plate boundary, where two plates are sliding past each other. So next we were supposed to list where we have different plate boundaries. So you will need to have a highlighter or some kind of colored marker. So if you want to take that out. So the first thing we need to do is to mark the location of convergent plate boundary. So if we click on our interactive map, we can see that there are convergent plate boundaries in a lot of places. One of the places that is close to us is the Juan de Fuca plate. So right here in Northern California, we have a convergent plate boundary. We also have one up here at where the Aleutian Islands are, which is on the southern half of Alaska. We also have convergent plate boundary where India is moving into Eurasia. We have one right below us where the Nazca plate is moving into South America. So you can mark any of those spots, or if you would like to mark the Philippines, it's any of these red lines. This is where two plates are moving into each other. So what types of geological features are formed at that? So let's go back to our animation to look at a subduction zone, because when two plates meet, usually we have subduction going on. And we can see the surface features that form. Usually we have a trench, we have volcanoes, we have earthquakes that happen, right? We can have an accretionary zone. So you can name those types of features. The big ones again are trench, volcanoes, earthquakes. Next, we need to look at where two divergent plate boundaries are. So we're going to take our convergent and we're going to look at divergent. In any of these white lines, mark our divergent. So in a different color, we're in the same color because it's a different map. Go ahead and mark where two different divergent plate boundaries are. So again, we also have one at the Juan de Fuca plate, right, where we have a diverging zone, which makes sense because we have converging and diverging. It's getting very close. We have divergent zones at Nazca. We have it again at the Mid-Atlantic Ridge. Right. So anywhere on these white lines, you can go ahead and mark as divergent plate boundaries. If we click on our red, you see the convergent plate boundary up here is on one side and the divergent is on the other. That's the one that's affecting us. So we're converging. So the geological features that are forming at a divergent plate boundary is we have mid-ocean ridge, right, which is a mountain range, right? We also have what we call a rift volcano, which is happening. So we have our mid-ocean ridge right here. And we didn't mention this earlier, there's a rift volcano, which is literally where lava is spewing out. It's not exploding, it's just kind of oozing out on the Earth's surface. And we also have fracture zones, which means that we have earthquakes. So we have earthquakes, we have a mid-ocean ridge, which is a mountain, and we have a rift, which is where lava is moving out, and we have earthquakes. Those are geological features that you would find at a spreading zone or a divergent plate boundary. Feature that we're going to look at is transform. So this is where two plates are sliding past each other. Right? And if you look at the divergent boundaries are spreading areas. Well, transform boundaries tend to be between divergent boundaries side by side. So what kind of geological feature will you find at a transform boundary? You'll find earthquake faults. At a transform plate boundary, there is no subduction going on. Without subduction, you're not going to get volcanoes. The transform plate boundaries, you have no subduction, and so you just have earthquakes. So now we get down to what are the convergent plate boundaries that affect California. So we go back to our convergent plate boundaries. Okay, so the names of the convergent plates that affect California are the North American plate, which we're on, and the Juan de Fuca plate, which we're moving into, and the Pacific plate. So I will take any of those three, all right, because we are on the North American plate. We are moving into the Juan de Fuca plate, which is affecting Northern California, and we're also moving past or into the Pacific plate, depending on where we're looking. Okay, so now we get to the age of rock. So now we're looking at the age of rock, and this map shows us when rock was formed. So we have oceanic crust, which is light blue, getting darker, and then we have the age of the rock going from youngest to oldest. So we're going from light blue all the way up to our chain, which is very old. And you can see that the youngest rock is, of course, on the ocean floors, with the youngest being at the mid-ocean ridges. And when we get to the continents, you'll notice that the oldest rock happens to be in the middle of the continents. And that would sort of make sense because the continents, remember, are not being subducted. They're just being, new rock is being scraped off onto them, or sometimes they are being separated. A new ocean is forming, as is happening right here. You're going to have these being separated by a rift valley that's happening, and a new ocean will form in between there. So rock tends to be scraped off on it. So if you look at the borders of the continents, they tend to be younger because rock has been scraped off onto it. And in the middle, we have our oldest rock. And on either side, sometimes we can find that there is a pattern of younger rock as you go. So here we have our green, then we have our blue, all right? But there can be rock that's missing, and that can be due to erosion, or it could be due to some other activity that has completely submerged or destroyed the rock that was there. All right, so the continents tend to have the oldest rock because, again, they are not being subducted. They're just being worn away by erosion. So when is rock considered zero age? Again, that would be right after it's just formed, which would be at the mid-ocean ridges. That concludes our video for today. If you have any further questions, please see your science teacher.